Okay, so we're talking about solutions and how we measure the amount of solute there is compared to how much is in the solution. So far we talked about percent solute and we talked about molarity. The third one and final one we're going to discuss in this section for Chem 1 is molality. And molality is very similar to molarity. Even the name is similar, exactly the same except for one letter, the L instead of the R. Molarity, we said, is capital M, which is moles of solute compared to liters of solution. So we just divide those two out and that gives us a number. Molality is a little m as opposed to a capital M, so it's even similar in that aspect. And it starts off exactly the same. It's moles of solute again. But the point of comparison is totally different. Instead of even considering solution, we look only at the solvent. And instead of a volume, we deal with the mass of the solvent. So we use kilograms of solvent. So the label M, just like capital M was moles per liter, even though it just said M, we read it as moles per liter. Same thing here with the little m. This is read as moles per kilogram. Okay? So, and that's really all there is to it. So we're going to take a look at some examples here. So let's go back over here and find the first example. And we have 15.6 grams of sodium chloride dissolved in 275 grams of water. So 16.5 grams of sodium chloride in 275 grams of water. Okay, so since molality is moles of solute over kilograms of solvent, let me make sure I got those numbers right, because I am old after 15.6, not 16.5. I had a feeling I did that. So let's make that 15.6. Okay, now, so I need to figure out my moles of solute. Solute's being dissolved, and that is the sodium chloride here. So we'll take 15.6 grams of NaCl times fraction line, 1 mole over 58.5 grams. Now why 58.5 grams? We go to the periodic chart, and you find sodium is 23.0 and chlorine is 35.5. So you get your trusty old calculator out, and we take 156 divided by 58.5, or 585 because I just get rid of the decimal point, and I get 0.267 moles. 275 grams of water, we have to change to kilograms, multiply by 1 kilogram over 1,000 grams. That's chapter 2 stuff there. And this gives us 0.275 kilograms. And we're going to divide those two out to get my molality, or my moles per kilogram. And so I punch into the calculator 267 divided by 275. And I get 0.971 moles per kilogram with this plain little m. Okay? All right. So that's example number 1. That's how you find straight out molality. So go back and find the second example. And we have 47.7 grams of Ki. And we need to know how much water we need to make a 0.251 mole per kilogram solution. So 47.7 and 251. Okay? 47.7 grams of Ki to make 0.251 mole per kilogram solution. And we want to know how much water, how many grams of water is it going to take to do this. Okay? So, again, this is the solute. So we have to change that to moles. 1 mole on top. And we know that sodium is 39.1. And iodine is 126. So that looks like 165 grams there. So we take 47.7 and divide by 165. And We make sure that 126 is right. It's actually 127. So let's fix that. That's 127 grams right there. And that's going to make that 166 here. And so we're going to divide 47.7 divided by 166, and we get 0.287 moles. All right, so we know the formula is molality equals moles of solute over kilograms of water, or solvent, whatever you want to call it. So the molality here is 0.251. The number of moles is 0.287. And we don't know the number of kilograms of water, X kilograms of water. Actually, we're solving for grams, but the formula asks us to solve in kilograms instead. So when you get a problem like this, and this is something you got to be careful of, when you have, we talked about this in density problems, you have your unknown in the denominator. You don't treat this the same way as if it was 2x equals 4 divided by 2. It doesn't work that way. You have to get it out of the denominator. So what I tend to tell students who are a little shaky on their algebra is to remember when you have proportions, you cross and multiply and set them equal to each other. So we got 0.251 x is equal to 1 times 0.287. And then we divide by 0.251. And the 0.251 cancels. Now, you notice that this is the shortcut that you can use in problems like this, is that when you do have a format like this without the 1, all you have to do is switch these two places around. You see, that's exactly what happened there. Okay? So the 0.251 went down here, and the x went up there. And, but, you know, if you want to do it this way, if you're more secure with that, that's fine. But basically, all you're going to do here is take 0.287 and divide by 0.251, and we get 1.14 kilograms. But that's not the answer. We want grams. So we take 1.14 kilograms and do the conversion method. Put kilograms on the bottom, grams on top, kilograms bigger, put a 1 there. Kilo means 1,000, put 1,000 up there. And this is going to give us 1,140 grams of water is what we're going to need to add to that to get the kind of solution that we are asking for. Okay? Next, third example. How many grams of Li2O is needed to be added to 750 grams of water to make a 0.4 molar solution? So 750 and 0.4. 715.4, okay? We have 750 grams of water and 0.400 mole per kilogram solution. And we want to know how many grams of stuff it's going to be. What stuff is it? I don't remember. I mean, why would I remember? I only made up the problem myself. Lithium oxide. All right, so lithium oxide it is. Li2O. Okay, so this is our solute. This is our solvent. So we can change this to kilograms, which we need to do. So 1 kilogram on top, 1,000 grams on bottoms, and we get 0.750 kilograms of water. Okay, so now what we're going to do is we're going to use the molality formula. Remember, the molality is looking for moles of solute, and we want one more step to get the grams of solute. We have to solve for moles first. So let's do that. So we are given a solution of 0.400 mole per kilogram is equal to the solute, which we don't know, so that's our X moles of lithium oxide over, and then the solute here is 0.750 kilograms. And to solve this, Now this one we can do real simple because we have the x in the numerator. We don't have to do the proportion. Although the proportion will still work, you put a 1 under that, cross multiply, divide, and it's fine. But if you know algebra well enough, you know all you have to do is get rid of the denominator if your numerator is where the variable is, which it is. In kilograms, this is moles per kilogram, so the kilograms cancel out. And 0.75 times 0.4 is 0.3. Don't need my calculator for that. So X equals 0.300 moles of lithium oxide. But we want grams. So we're going to have to convert that to grams. We're putting moles in the denominator and grams on top. So 1 mole, again, go to our handy dandy periodic chart here. And we got 6.94 for the lithium. There's 2 of them, plus oxygen 16.0. So that's a 13.88, and 16 is 19.9 grams. So multiply that out, and that's going to give us, 5.97 grams of lithium oxide. And there is your answer. You now are able to do all 3 types of molality problems. So we have practice problems at the end of the script here, and 5 problems. Have fun!